I prepared presentation about 5 essential tools we use in Kiwi.com and I use in my pet projects. And those are tools or libraries I consider to be like the key players in a good, scalable, and large application. Now, so imagine that you are about to build really something really life-changing. And the life-changing thing is that you are going to build a new startup. And you are building it today. And let's say I will guarantee you that this startup is going to be super successful and very big. And I'm talking about scale of Facebook, Google, or even Kiwi.com. And now my question is, what technologies would you use to build your JavaScript frontend or JavaScript client devices, and etc. So think about it a little bit, and I will help you with the decision, or I will give you my opinion on this. So if you want to build a large application that is going to be scalable and going to be here forever, and if you are building a startup in 2018, that's important, you are probably going to need these elements. You're going to need a mobile device. You're probably going to need a tablet. And tablet is just a different version of mobile device, but there are still some quite significant differences. And you're probably going to need a website. And since I already said who is using React, so it's quite obvious that I am a React developer. And we are actually all full-stack JavaScript developers, so we should be able to build anything from server to website, even mobile devices. That's not the key technology or key tool yet. So since you already know that we are going to build a mobile application, I'll give you an example of such a case. So let's build this very small application. And this application is actually written in React Native, which is still not the key technology. We are ramping it just up. And this application is pretty simple. It just shows the history of all the payments. You have the rows here, and you have details about the payment in each row. All right? Now, as I said before, we are probably going to need a website as well. And it would be pretty nice if I would have basically the same payment history in my browser or in my administration of my product. Now, as you can see, the application is pretty similar. There are some differences though. There are differences like, for example, the colors of the statuses, which looks like a small thing. It's only for the demo purposes, but it's different. It's important that it's different. I will get into this later. And the most significant difference is that the layout is completely different. What I mean is that in case of mobile device, you have this navigation here, you have the header here, and in case of website, you have the menu here, right? So the layout is completely different. Some parts of the UI is different, but at the end, we are sharing. We want to do the same on mobile device and on the website. Okay, and this is my first key technology I want to show you, which is React Native Web. React Native Web basically allows me to write React Native application, or let's say React application that runs natively on iOS device, Android device, and runs on a browser as a proper website. I will show you a demo now, so you will believe me that this actually exists and it can run. So this is the application. It's basically the same. I took screenshot from it in my iPhone XR. It works. It's alive. And since it's React Native, then if you know it, okay, it's not very smooth now, but if you know it, in real life, in a production build, this application would be proper native application with 60 FPS with everything you need, except it's written in React. Now I also have the website here, which, as I said, it's pretty similar, but it runs in browser. Now, the reason why I do it like this is that I can write one React code and I can run it everywhere. I will show you How does it look like from the code perspective? So this is first component. I'm going to show you a few components. So this is first component, which is payment list. And payment list, so you get oriented, is basically this part without the navigation, without the headers, right? So you can see here that here is the scroll view. There are these payment rows. I'm iterating over the payment rows, and there is something like something more which I will cover later. Now, if you look at the React code itself, you cannot really tell whether it's written in React Native or in React. Because yes, I'm using the same names here that are in React Native, but at the end, it's just a React component, and I can write whatever implementation I want. I will show you second component, which is component of the payment row. And again, payment row, we are getting smaller, so payment row is just one row in my payment list. Now, it's pretty similar. This is just a normal React code where I'm composing the components. You cannot really tell what is the implementation of the components now, just the React. And then I have these styles and something I will cover later. So as you can see, I write one code and I can run it everywhere. And the reason for this is that React is just an abstraction. So even if you are writing your divs in your application, you are never writing HTML. You are always writing just an abstraction, and React is doing the magic that runs it in a browser. So except in my case, the abstraction is just a little bit different. So let's go back to my presentation. So that's React Native Web. And we will touch it a little bit more later. But now, let's wait a bit. Because there is more. It's not only about the React code. It's also about the data requirements. So let's have a look again at the application. So here's our payment screen, payment list. And payment list contains one row. And it requires name, price, city, and any other data what I need to show. Now, that's only one row, but I have many rows. So my payment list requires all the rows, and each row requires the data requirements I showed you before. So at the end, the tree of React components looks something like this. I have the payment screen. The payment screen contains the payment list, and there's this, the navigation, the header, and each payment list contains many rows, and each row contains a component for name, price, city, which are rendering the specific field with some style. But if you look at it, those are actually my data requirements. I'm describing here what I need. So if I go back, I can say that in order to render payment row, I need name, I need price, I need city. And in order to render a payment list, I need payment rows. And this is exactly what is my second technology, GraphQL, for. So GraphQL is crucial technology we use basically from the very beginning. We started Office in Prague because we realized that this is super important in order to build the components really well. So I will show you the demo again. In the code. And let's have a look at the other side. So now I'm showing you a last component, and that's the smallest component you can find in the application, which is the status. So the status can be fail or paid, right? So again, I do have here the React code. The React code is pretty standard, except I do have here some differences, so I can render the styles depending on the platform. So you can see the real example, how does it actually work if I do it, if I just hard code it there. Not that important. Now, here are the styles of my icon. And important part here is this small fragment at the end of the file. In this fragment, what I wrote here is describes my data requirements for the component. So I described that in order to render this component, I will need this status. Okay. Now let's have a look at the row. That's one row in the list. So you already saw the React code, the styles, and again, here are the data requirements. Now, super important thing here is that I am writing here only what I need for this component, and I'm not writing here the data requirements for the status icon. I'm just writing here that I'm using status icon somewhere in this file, and I don't really describe what is inside. I don't care about this. So this way I can achieve really nice encapsulated component where I describe all the data requirements that are necessary in order to render the component. And the same applies to the whole payment list where there are rows. So you will see it here. Again, I write a query here that requires some ID because I need the ID somewhere in this component. I'm probably iterating the payment, so I need a key for React, obviously. But again, I just said I'm going to need a payment row, and I did not write here the data requirements for each row. And this is super important difference between very well-known REST APIs and GraphQL. So I will try to explain the difference so it's very obvious. In case of REST API, server is you have two parts. You have clients and you have servers. And server is the part that is actually describing what is going to be returned from the server. So when you get something from the endpoint usually returns huge JSON response, and it's up to client to take the response and distribute it in the React tree of components. Now, in case of GraphQL, it works a little bit differently. Again, you have client and you have server, but client is describing what it actually needs, which I showed you in the fragments. And then there is this special framework I will show you later. And it will take these data requirements, send them to the server, and server is responsible only to return these data requirements, or to fulfill these data requirements. And we use Relay in order to achieve this. Do you know Relay library? Nobody knows Relay? Okay, I see. Okay, but not too many. So Relay library is a library we use in order to collect all these fragments, somehow merge them together so they are optimized, and to send them to the server. And Relay takes care of first sending the request, and then of course getting the request back, the response, and distributing it into our components of React components. Now, the nice part is that GraphQL is basically a tree structure, so it perfectly fits to our React components because even the React components are tree structure. Is it clear now, or did you get lost? I think it's pretty simple, but if you are not familiar with the technology, it can be really confusing. Cool. So, all right. So GraphQL for the win. So I already showed you 3 parts of the stack I consider, or we consider, to be really crucial parts in order to build good application or good JavaScript client. And this is React Native Web for writing the React components that are able to run natively in our clients. GraphQL in order to fetch only what we need, and Relay in order to merge these two concepts together, the GraphQL and React Native Web. Now, if you want to build a big application, and since I said you are building a startup and it's going to be here forever, then you will write thousands and thousands of components. And we already did. And you can imagine that you will do many mistakes in your code. Even though if you are the super good programmer, you will do mistakes. It's okay. But we have tools for it. We have tools to catch these errors. So let's have a small quiz. And are you able to spot an error here? It's not a syntax error. All the brackets are okay. Don't worry about this. But can you spot it? Don't worry if you cannot, because I use this example so you cannot find it. The error is actually here. Maybe you still don't get it, that's fine. And that's my point. Because if you want to find such an error in your React application, you have to know the context of these components. And actually, you would have to go into this component, read the internal implementation of this component in order to understand that something is wrong here. And I will show you what we use for to catch these errors. We use Flow for this. And Flow is basically a library that or it's a tool to catch these typed errors, because we type every component, basically every single line in our code is typed using this technology. And if I would run the code I wrote before, it would throw this error. And I will help you to read it, because if you are not using Flow, it can be a little bit difficult. So let's have a look. There are 2 rows. It's basically the same error message, but written twice a little bit differently. So first row says that property data is missing in 1, which is something like this. Don't worry about it now. But property data exists in props 2, which is here. So in other words, I am using data here, but I should not, because it's somewhere it exists. And you can read it differently. So property payment is missing in 2, which is here, but exists somewhere else. So in other words, I am not using property payment here, even though I should, because it's somewhere expected. So I will try to say it completely differently now. I am using property data here, but it should be payment. This property should be called payment. And this is basically what is written here. And so you can see that if you learn how to read these sometimes complicated errors, you can fix these issues before you even send the code into your continuous integration server. This is super important, especially if you have really many components. And testing, of course. That's the last bit that is super important in order to have large applications that are here forever. Now we use Jest. We use Jest because it's really fast. We like the API, and we like some cool features that are in the Jest framework. And I will show you one simple test that shows my favorite feature that was introduced like 1 version ago, but it's super powerful. So this test, what it does is it takes the link component, and this is the link component is our implementation of the link, because we have some additional logic there. But at the end, it should render a link, the HTML link. What it does is it renders the component in the code, and then it tries to take these. It's called snapshot of the rendered output, and save it somewhere for later. So in this case, what Jest is going to do, it will check this line, it will take the output, the rendered output, and it will actually write it for you here. So when you write it for the first time, the result of your code is going to look like this. So in this case, Jest actually effectively written code for you, which I think it's a pretty cool feature. Now when you run the test for the second time, it will not write the snapshot again. It will just check the snapshot and compare it with the actual response or the actual rendered output. Now, even though this test maybe looks cool, I would recommend you to use these kind of tests only for small components. So let's say only for leaves of your React application. And the reason for this is that if you write this test for a large component, and let's say for our payment list, then if you change something in the link that is somewhere deep in the tree, then it will crash many tests. So what I recommend is use it only for small tests in order to check that the output you expected is actually what you expected, what you got. Cool. So this is how it looks like when it actually crashes. You'll get the diff of what you got, what you expected, and you can easily find an error, change it, regenerate the snapshot if it's necessary, and job is done. As I said, it runs in parallel, which is very important in large code bases, because if you are writing code, you are sending it into your continuous integration server, you want to get a response very quickly. And it runs on many cores, so when you have hundreds and hundreds, maybe thousands of tests, then you really want to get a response in minutes, maybe seconds. So do this. If your tests are slow, maybe you are writing them in the bad way, or you are using just one core, which you could improve easily. So we actually have, on my project I'm working on, there is pretty huge set of tests, and we run it on many cores on a large machine in order to get response in 1.5 minutes. The last thing I would like to stress here is test pyramid. Is everyone familiar with this picture? I think it's important, but not everyone said yes, so I will explain it a little bit. So what it actually says is that you should write many, many unit tests, because you are testing the small parts of your application, and those tests are easy to write. They are super easy to run because they are fast. They don't need many resources, and you can cover pretty large part of your application. There is a problem though. If you are writing just this, if you are testing just the small bubbles in your application, you cannot really be sure that they work together. So you should write like the higher level kind of tests, and those tests lies here. And the thing about Jest is that you can write them. You can use Jest from here to here. The last part of the pyramid, those are UI tests, where basically you will take the whole website and your robot is going to click on the elements and check that the website is actually doing something. And the problem with these tests are that they're relatively easy to write, but they're very expensive to maintain into the future, and they are very expensive to run them because they are slow and they are flaky. So you should move some tests from here to the integration layer of your tests, where you can write them in Jest. They are very stable, very fast, and you should keep these UI tests only for the business critical path in your product. So in our case, it should be like the order process, for example. But I would not test with it that the button when I open the modal is okay. Now, also think out of the box. I will show you one idea after this slide. But what I want to say here is that it's not only about UI tests, not only about integration tests, but you should really test your ideas. So if you have idea about your project structure, and again, we are doing it with a big scale, when you have tens of thousands of components, maybe you should write the tests on a repository structure. And I will cover the idea about repository later, because I think it's very important in this case. But let's recap it for the last time. So we do have React Native Web. React Native Web helps us to write one React code, do some platform tweaks, because it cannot run everywhere just by default, but then you can run it natively in iOS, Android, and website. Reusability is good, so this should be pretty obvious. Now, we do have GraphQL in order to fetch the data in a clever way from our server. And thanks to Relay, which connects these two concepts, we can take the whole React Native or React component, even with the data requirements, and just run it everywhere, just move it somewhere else, and it will just work, because we are carrying everything, styles, even the data concepts with us. And there are some tools that will help us to maintain the code base, which is Flow for the types. I showed you the arrow with the properties, and the Jest in order to run the tests. Now, here is one highly opinionated bonus that is very valid, and it's based on this article. Do you know that the biggest players in our market are using basically single repository? Maybe you don't know, maybe it's a surprise for you, but it's true. And the reason for this is that it simplifies the development in a big way. And we are actually trying to change it in our code. So I will give you an example of what is problematic in our case. So we do have hundreds and hundreds of developers, but we are talking about, let's say, 200, 300 developers. And we have more than 1,000 repositories in our private GitLab, which is a lot. So if you say differently, we have more repositories than developers to maintain them. And this is getting pretty crazy. So we do have folders. Folders work as well, just as well. You just have to develop some additional tooling on top of it, but you can store everything in one code base, and you will be happy forever. So think about it. Maybe you don't agree with me. In 5 years, when you are going to have 1,000 repositories and 10 developers, you will agree with me. That's all from this talk, and I would like to hear some questions from you. Thank you very much.
Mark, you said that you use Jest to test small components. What would you use for large components then?
Well, maybe I didn't describe it well. We use the snapshot testing for small components. Okay. We do use Jest for everything, but the thing with Jest is that you should keep the snapshot as small as possible. So if you would if you'd like to snapshot large component, then it's okay, you can do that. But there is a pretty high chance that during the code review, your colleagues are going to ignore all these changes because, let's say, you will change 100 lines in 100 lines of snapshot. So you are just ignoring all the changes, not really reading it. So that's also pretty good advice why not to do it. And we realized this a little bit late. But we're still changing this, and we are teaching everyone do it only for small parts of small components or small objects, small arrays, snapshot whatever you want, but keep it small, keep it simple. Any other question?
Are Flow and Jest specific to React, or can it be used for other?
They can be used for whatever you want. They are not specific. They work, at least Flow with React works very well together. So we like to use them together because it just makes sense, but they are not specific. The same applies to the React native web concept. It's not specific to iOS, Android, and web. We met some folks from PlayStation, for example, and they are using it in their custom devices that doesn't run on iOS or Android. They use it in Windows 10, Windows 7, whatever. So it's really just an abstraction, and it's important the idea that the reusability is good and you should benefit from it, not to write it many times, not to hire many native developers just to copy what you already did once.
Like this, using Jest, we can test in all the web, mobile as well as tablet. You test in 3 modules or for the testing like.
Well, yeah, there is.
We don't know we have a button here. It looks in mobile somewhere here.
Yes.
And tablet somewhere here.
Yeah.
So how our test works actually?
Well, when you write code in React Native, you have pretty high reusability of the code. So at the end, let's say you have 80–90% of the same code. So you just test this code and it's platform independent. There are some small differences, and in this case, you just write test that tests iOS version, Android version. So you just switch, the context, test it once, switch the context again, test it again. You just write basically 3 more tests because you have more implementations. So you can do it pretty easily. We do it. We just switch the platform, test it.
For the QD side,
so
we have what is the percentage of effort spent on testing? Like writing the JS test. What is the percentage of effort out of 100% of the product? Complete development. What is the unit testing? How much effort is spent for this testing?
I'm not sure how to measure this number, to be honest. We just kind of naturally write JavaScript code and kind of naturally write tests for it. And it's
because UI is mostly the interface.
Yep.
What we see, but the test cannot be the actual look and feel. The test will be passed, but at the end, the look and feel matters.
Yeah, sure. Well, as I said, those are there are different kinds of tests. So when you are testing just React components or the implementation of the React components, some business logic in your client, you just test it normally. And then you have different kind of tests, and we actually use, I think, Detox for iOS devices, Detox for Android devices, in order to do some very high-level tests. Then we run some Cypress tests on front end, so those are again different tests. So you just write your tests, your test suite, in order to cover all the issues you already have, or just the freeze, how does it work now? So yeah, you have to write tests, and you probably spend more time writing tests because you want to keep the product forever. But I guess it's normal. I would say don't write stupid tests. That's what's sometimes happening. The developers are writing tests that are not useful or just pointless, basically. But I'm not sure if I answered your question really well. Maybe we can chat later so you can ask me differently.
You praise monorepos, but what are the drawbacks of monorepo? Is there anything that people need to be aware of?
Yeah, as I said, in my opinion, the biggest drawback is that if you don't have good tooling, if you are just focusing on the development and you don't stop and you don't think about it and you don't write some additional tests of the monorepo or the tools in order to handle all the issues and the large-scale refactoring issues, then it's going to be painful for you. But I think it's a bit everything. When you just develop blindly and you don't invest into your tooling, then at the end, after 5 years of development, you will just have huge mess in your code base. So this is similar, just a different problem. So we are actually, we don't use it very heavily, as I said. We have many, many repositories, but at least some parts that are closely related, we do use monorepo, and we develop the tooling for these small monorepos, which we have many of them. But at the end, the nicest end of this story would be that we would just merge this monorepo together and we would be somewhere else. So we can do these large-scale refactorings very easily. The great example of this, why it's necessary, is, for example, the GraphQL proxy, as Michael showed you. We implemented this GraphQL proxy on top of our all microservices. So we do have this service, we use it, it's cool. But now we are moving into so-called GraphQL native, when we want to move from this proxy and move all the logic into our Python code. So we don't have this additional layer of abstraction basically on top of our applications. But since you have thousands of repositories, it's pretty difficult to make it work just flawlessly. You have to implement it there. It's pretty painful. Thank you.